This video clip looks at the particle model and how it is related to pressure. As a quick starter, pause the video and see if you can describe to yourself the arrangement and motion of particles in a gas. In terms of arrangement then, the particles in a gas are very spread out. In terms of their motion, they're moving very quickly in random directions and at random speeds. Having recapped the movement and arrangement of particles in a gas, pause the video and see if you can answer these two questions. Firstly, if you're sitting in a room, is there any pressure acting on you whilst you're sitting there? And secondly, is there any pressure acting in a balloon? The random and rapid movement of gas particles means that they are constantly colliding both with each other and with any sides of any container that they're in, or with any object within that container. They're therefore exerting a force on the sides of their container or on any object inside it. So gas particles will be colliding with us whilst we sit in this room, but they'll also be colliding with the inside and outside of the balloon. So the answer is yes, there is air pressure acting on us sitting in a room. There's also air pressure acting in the balloon and outside the balloon. We define pressure then as a force acting over a particular area, which leads us to this equation that pressure measured in newtons per metre squared is equal to force in newtons divided by area in metres squared. And I've rewritten the equation there as P equals F divided by A. Typical atmospheric pressure at sea level is 100,000 newtons per metre squared. Now, although I've not shown it in this slide, there are other units for pressure. We could measure in newtons per centimetre squared, for example, if we were measuring a much smaller area. And there are other units of pressure such as PSI, inches of mercury, and various other ones that have been used in industry over the years. However, the standard unit is the Newton per metre squared. So now I'll pause the video and see if you can explain why there is pressure acting on us in this room and why there is pressure acting in a balloon. So in terms of pressure acting on us in this room, air particles are constantly colliding with us, exerting a force over a surface area, in this case the surface area that makes up our bodies. In addition, because there is an atmosphere on Earth, there is the weight of air which is up above us pushing down on us, which also creates pressure. If we imagine that that weight is a force and the area is the area of the top of our heads, then that force divided by area tells us how much atmospheric pressure is, and as we said earlier, it's 100,000 newtons per metre squared at sea level. The air particles inside this balloon are also moving randomly and rapidly and therefore colliding with the sides of the inside of the balloon. This means that they're exerting a force over the surface area of the balloon, which means they're creating a pressure. At the same time, air particles outside the balloon are colliding with the outer surface of the balloon, which means that they are also exerting a force over that surface area and therefore exerting a pressure. This stops the balloon from expanding further. Where the outside and inside pressures are the same or equal, then the balloon doesn't expand. Again, at this point, pause the video and see if you can answer this question. I've got a tin with a lid stuck into it nice and tightly, and it's sitting on top of a Bunsen burner. So I'm heating up the tin and therefore the air inside the tin. If we heat the tin with its lid still on, what do you think will happen and why? Heating the air inside the tin causes the temperature of the air inside the tin to rise, and therefore the particles of air inside the tin will move more rapidly. If they're moving more quickly, they will collide with the inner surface of the tin and its lid more often, but also with more force because they have more kinetic energy. This increased number and size of collisions means that we're exerting a larger force over the same surface area of the inside of the tin, including the lid. That means we're increasing the pressure. I would therefore expect that if I did this long enough, the tin lid would pop off. So now you have an understanding of air pressure and how it's related to particle theory, particularly that in gases. I would recommend having a look at these two YouTube clips and see if you can explain what's happening.